Hey everybody, we have a Sanyo PLC-XM100 DLP or LCD projector that was sent in for no power. There's a local DJ company. In fact, you know what? Let's give them a little plug. If you happen to live in the Delco area and you need some DJ help, give these guys a shout. There's their phone number and everything. They've sent me a few projectors to work on. This is the third one. There's a pair of Sanyos I did last year. If I remember, I'll put links somewhere. I'll at least have them in the description. One had no power. One I think wouldn't turn on or wouldn't ignite. Like it had power but didn't do anything. This one allegedly is just dead. So let's move. This is Fine Dog. Got a power cord. Let's see if we get anything. These projectors should at least show you something. Even if the lamp door was open or if the filter door was open, you would at least get something. The fact that we're getting nothing is potentially good. I prefer no power versus some power, because no power usually means that there's one problem affecting the entire power supply. Some power can be a little more tricky. So let's move around. Let's pop the lamp out and just make sure there's nothing on the timer chip that might be shorting out some pins and causing a problem there. So let's take a look at that. All right, let's loosen that. Open that door. Actually, these doors come off. See that little notch right there? Then there's another on the other side. So that fits down in those notches, and then you can pop the door off. I did show this on the other video, but the other thing you can do, make sure this screw is just a little loose, and then it'd be easier to do with a flathead. There's a little right here. So this, you can kind of see in there, that's the door switch. When the cover goes on, where's it at? Here, thumb, there we are. That little tab is what hits the door switch. So if we find my flashlight here, I will show you. But there's a actually, you can see it fine. I don't need the flashlight for this. So there's the little tab, but there's this thing next to it, this metal, there it is, that metal piece. So you just put the screwdriver in and turn it, and it pushes that metal piece over and latches the door switch into position. So this now thinks it has the door on, or it would if it was seeing power. So looks like they have an old OEM lamp in here, going by the timer chip. 610-347-5158. That does look like an original. Let's see, it comes out. Yep, definitely an original. Chip looks okay. I was looking to see if any of those pins look weird, because it plugs into this thing that you guys can't quite see. There we go. Oh. I didn't have this set on the lamp when I recorded it. Alright. Hopefully I remember to edit that part out, but I had the camera pointed off to the side and you guys didn't see me take the lamp out. So we loosen up 1, 2, 3 screws. And then grab the 2 handles and we just kind of work it up. There we go. These are pretty snug. So I was looking to see if that connector had any problems, or if this connector down there had any problems, and that looks fine. So I think we're going to be opening this up. Alright, first things first, I'm going to take the lens out. Oh, that lens did get hit. Wasn't shipped, they dropped it off. So let's take this lens out, and since the top of the lens here is not protruding any of the glass, I'm just going to set a piece of foam on it. That'll keep the dust from settling. Now we can start taking it apart. Alright, we'll get all the screws on the top out first. So we'll take that cleaning door off. That covers up the optic so we can get in there to clean everything. 1, 2, 3. Okay, that should... Yep. And we got a couple on the back and then the bottom. Maybe this is a Japanese manufacturer thing, but I've noticed they have arrows pointing to the screws, kind of like Sony does, and JVC. Then in the filter area, take the filter out. This is this a, yeah, that's a, oh no, well, that's a cartridge kind. Yeah, so this kind, there we go, get a little snug there. So that's a cartridge filter. These are replaceable. They also have ones that are just foam, which I think are just as good. So we need to get the last screws out that are in here. There's one. See if you guys can see it right there. And then the two on the sides. Make sure you guys can see what I'm talking about. Right there. Nope. Let's bring the camera up a little bit. There. And there. Come on. Oh, that wasn't very smart. I'll get it out though. Not a big deal. Alright, came out. So now the top should come off. Let's see. Oh wait, no it won't. I forgot one more. I always forget that one because it's kind of in the middle of all the connectors. Kind of blends in for me a little bit. Alright. I think we're going to have wires connected to the front, to the behind there. Oh! And, wow, I'm getting way ahead of myself here. 1, 2. Now that'll do it. Now they do have an arrow for one here, but I'm pretty sure, let's see, you guys can see it. Yeah, that one, they have a wire, but that just points to the bracket that holds the filter. So that one's going to stay. It's just those two. So now, zoom you guys out a smidge. Alright, now the top should come right off, and then I'll unplug, unplug the LEDs. And we're actually going to pull the LED board off so I can plug that back in, because this is incredibly helpful for the troubleshooting. I'll plug that back in. I'll set this back here. And so you guys know, those screws are the helical thread type. All the rest of the screws I've taken out so far are fine thread metric. So remember that fine thread metric holds the case on, and the helical threads hold the boards to the plastic. Plug that back in. So the power supply, unfortunately, is down inside. It's kind of a pain in the patootie to get to. I'm trying to think if there's a better way to go about this. So I see the ballast down there. I think we're really just going to have to take it all the way apart. I will see if we're getting any low voltage. So let's take the shield off so we can get to the main board. Some people might ask, why are you repairing a 16-year-old projector? Something like that. It's a fairly classic projector at this point. The reason is it's very bright and it has a really nice picture, even though it's not technically well, it's not high def. It's XGA or way to set it. Yeah, XGA, which is fine for a lot of presentations and just decoration and stuff. That's plenty. You need the brightness, and that's what you'll get here. These are really bright. Oh, that was not good. Can't plug in until I get that screw out. I was hoping that would have stuck to the drill. I see it. One moment. There we go. Got it out. So down here, this is where the power is coming in from the power supply. There are some chokes and capacitors there. They're probably fine. My guess is that the actual power supply itself has a problem. So let's just make sure. I'm going to set the meter here. I have the door switch bypassed. So let's plug this in. Oh, I thought I heard something. Yeah, there's something. So we have some power, which isn't great, but it's fine. Yeah, I'll make it work. So let's see. What do we have on our test points? Let's see if we get anything. If I see 6 volts on one of these, that would be cool. Nothing. 2.5, 0, 0. I may have to pull my service manual out for this because I'm seeing 2.5. That's interesting. I really wasn't expecting to see anything up here. So we'll go down one more time. So we have ground. Should be something. Should be something. Should be something. Should be something. I don't have the manual pulled yet, so I don't really have anything to tell you. So this, I'm thinking, should be 6 volts. See how it bumped up for a moment when I unplugged it? So when I plug it back in, let's see if it bounces up to 6 for a moment and then goes back down. No, right to 2.4. Alright, well, that's fine. Let's get inside and get to the power supply. So my past experience, I think I can leave these, but I do have to unplug that fan, ballast control, temp sensor, shutter. Yeah, shutter control. We'll do the LCDs last. Lens control, another fan, and then just a whole bunch of fans and some other sensors and whatnot. Just gonna unplug all of this. See, I left these in because they're zip tied to it, and it's kind of easier to leave them that way if it's already dressed like that. So let's get these. Pardon me. Now, if this was an Epson, I probably wouldn't be working on it first off. But secondly, I would be really cautious about disconnecting these. But for some reason, Sanyo, well, these days it's Panasonic, but Panasonic, NEC, just build LCD projectors better than Epson. They're not a pain to deal with. Like, you can work on them without worrying about the whole thing just falling apart on you. I don't like Epson. All right, so then next, let's see, got that. Let's see, so I want to take that. This is going to loosen up, so we'll take that bottom screw out. This fan, I remember that one and this one. Okay, and that should be all the fan screws. Fan comes out. You can see part of the power supply, but I want to take this whole thing has to come out, and there we go. Right there, that one. So that should release this side. Yep. And then this side, I think was just down at the bottom. Yep. Actually, that screw I took out can probably go back in, but we'll see. Let's see if this board comes out now. Yep. And this metal plate, you'll see why. It is kind of convoluted. Because this is the block we have to get out. This thing. The whole block. I want to get that out. So now we just got to figure out where it's held in. So here, that one. Let's get this top ballast off because we have to unplug, oops, I gotta find that screw. We have to unplug the lamp wire right here. This has to come out. Like that, good. And then this bracket. That gets that wire out of the way. Not there, not that one. Almost. I think we just have one more right here. Yep, it's coming up. Alright, and then I have to disconnect the there's a temperature fuse wire. It's kind of down in the back.
Two hours later.
How do we want to do that? The fan, you know what? We're gonna take the fan off because I don't want to undo all those wires. It helps with putting it back together if the wires are dressed nice. So we're gonna take the fan off. Now there's no rhyme or reason to when you should do that aside from a case-by-case basis. So you leave the fan on if you can, and if you can't, you take it off. I'm sure in the manual it tells you to do it a specific way, but we're not worried about that. We're just worried about getting it how we need it. So that's what we did. Power supply is out. Alright, so I was looking at this a little more. I pulled the service manual. I worked on one of these before, but it had a different problem. But I did work on a 150, I think, that had a similar issue. So I figured I'd check down that same direction. So I want to make sure the standby is running right. The 5-volt output is going up and down. It's not staying at 5. So it makes me think that maybe that switching regulator, STRA6079N, might not be responding. If we look down there, we can see pin 8 that comes off of the transformer, which is right there. We should have high voltage. I'm going to call it high voltage, but we should have, 150 some odd volts on that. 164. That's what I expect to see. So let's check the VCC to that chip, pin 5. It should be 32 volts. I verified that in the data sheet for that STRA6079. So let's see if we have that 32 volts or if it's something else. 9.8. So I'm not a math genius, but 9.8 and 32 I believe are different. So it makes me question that capacitor. I'll show you which one I mean. Let me just turn off power. Got this plugged into my dim bulb tester in case I accidentally short something. So the capacitor I'm wondering about is this one right here. C640. Yeah. This one right here. So this is rectifying the bootstrap circuit that powers that chip. And if we're getting 9 volts there, that's not right. I don't know if that capacitor is actually bad or if it's the chip, but from past experiences, most likely that capacitor went leaky and it's not rectifying right anymore. So if we were to throw a scope on it, we'd probably see the voltage all over the place. So I'm going to remove that and we're going to change it. Alright, let's get that cap removed, and then we'll pop a new one in. So the first thing I'm going to do is wet the old solder up. I'm just going to flow some fresh solder onto the old solder. Oops. This will help the wick and or pump clean those pads up. Alright. Now let's see if I can pull it out. It's got that glue, so I'm going to try and just wiggle it out myself. Yeah, there we go. There's one leg. It's really difficult to do with a camera in between, so just bear with me. There we go. So it's got some mastic glue on there, but I'm pretty sure that's the problem. 22 at 50. We'll check it in a second, but let me clean those pads up. And you know, I should have thought about that. A 22 at 50, you wouldn't have 9 volts feeding a 22 at 50. I mean, I guess you could, but that's probably not what you would expect. If it was 9 volts, you'd put in like a, 20 volt, something like that. Oops, almost. It's almost time for a new solder pump tip. Okay, let's check that capacitor now that that's cleaned up. Alright, let's get that over here. So we need 22. We got nothing. So no microfarads. So that thing's just dead. Alright, let me get a new one. Okay, let's put the new one in. Let's see, the white spot is negative. Yep, the top. I gotta clean the top of that up. Alright, that's cleaned up. A little bit of solder splash. Let me just get it out of the way. Alright. And then put our capacitor in. Wait, negative. Negative is the cup. Yeah, the cup shape. So negative, so this way. Now before I solder it, let's just look and make sure. Positive is going to pin 5, that looks right. Good, 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 good. Let's solder this in. Alright. So we'll do this one. And then this one, I'll trim it. And I'll plug it in and hopefully see 32 volts there. Let's see what we got here. I have it plugged in and I'm still not getting standby lights, so I think something's still wrong. It's better, 23 volts, but still not 32. Yeah, see, that's the rectifier for it. C642 maybe? That. I'll show you what I mean. So if we're getting 32 volts, too much paper. All right. So we're getting 32 volts here, and I might tape these together at some point, but for now we're just gonna, oh, you want me to go tape it real quick. So we have 32 volts here. We should have 32. We have 24, and it's coming from through here. So we could see 637. No, that does not look like an electrolytic. It's not, but C642 is an electrolytic. Interesting. Diode check's good. Let's check that resistor and just make sure it's 4.7 ohms like it should be. I'm pretty sure it is. I'll be surprised. I mean, I guess it could be higher if the capacitor was bad and taxed it maybe. I don't know. Doesn't really add up in my head. 5 ohms, that's what I'd expect. I'm wondering about that chip now. I'm going to go grab the data sheet on that chip and we'll figure it out. Alright, we're back. It's actually been about a week. I had to wait for the chip to come in and a couple other things. So I went to change the chip. I actually did all this off camera just so I could get an idea of what was going on here. And I'm going to start this video over. And we are back. Things are set up a little different. It's been a few days. I had the weekend and some stuff to do. But anyway, as it was when we stopped, we were getting what seemed like a low standby 9.6, but that's actually okay. I found out I do have power, like it is switching, because on the 5 volt standby, come on, oh no, that's not ground, wrong ground, that's the pre-low voltage ground. Let me just get around here so you guys can see. Turn the light on. What I found is that the 5 volt, come on, it's coming out at like 2.5. If I can get a good ground here so you guys can see what I'm talking about. Like it was coming up about 2.5 volts. Of course, now it's not. Let me reset it. But I was getting about 2.5 volts, and that's not good. It's not enough. We got about a 0.5 volt now. So I think we have another bad capacitor. I already pulled the glue off, but I'm pretty sure this capacitor is bad. It's a 470 at 16, so I'm going to go swap that out, and then we'll see how it works. Okay, so that's switched. Before we put power to it, let's see what this old cap says. Come on. So 430 instead of 470. That puts it well under its spec. I think these are 5%, 105C. But that doesn't look good. So let's go back to volts here. Let's put some power on and see what happens. Alright, keep an eye over in this area, see if we get any lights. Hey! Look at that. Standby lights. I like that. So what do we have on the output here? Of course, it should be throwing a pile of errors because nothing's plugged in. So let's see if we have 5-volt standby. Hey, look at that. That's what I want. That's beautiful. Alright, let's unplug this. Get my meter and scope out of the way. And let's get it kind of back together so that we can plug all the wires in and see it come on. Okay, so to reassemble, get that foam out of the way. Get our chassis. Unplug my little bypass tool. And then we will need to plug in the PFC 380. We're going to assemble this enough so that we can get power to it. Set that back in. The power plug goes like that. Alright, so we need that and this one. Then we have a couple for here, so let's see, going into the bottom we have one, looks like 2, 3, there's arrows pointing to where they're supposed to go. Now plugging in the thermal and AC into here is going to be a little tricky. I kind of remember the wire being tight. So let's see, let's plug those sensors. There. Let's see. Fan, low voltage. So this is going to be tricky. That right there. So before, I'm pretty sure I took all of this out. Maybe I'll do that again. Let's see. So let's try taking out just the optics, because I really think trying to get that in there and push that all down, yeah, see, that's gonna fight me. I'm pretty sure last time I did one of these I had to take that out too. Okay, so I'm seeing that those top screws are likely complemented by screws in the bottom. So let's put those back in, and we'll just take out the screws that are holding that metal to the chassis. Oh. Alright, so it's loose, but well, I'll show you. So down in here, get that main board straight. So this has to come out the basket. Can I get this out without taking the basket out? I'd really rather not. Doesn't look like it. Oh well, such is life. Oh, that's actually enough. Plug that. Then we have our lamp. You know what? Let me pop that lamp wire out. There we go. We'll set that there. This is good. I feel much better now. Let's see if we can lift this up. Yep. So let's put this in now. Okay. Alright, so I just kind of, well, you didn't hear it click, but that's in there now. So that's plugged in, so now we can put the rest of the optics back in. But before we do that, we need to mount that fan. So So let's see, we'll have that, and we'll have the fan wire go that way. Yeah, that'll be fine. I was going to unhook the fan entirely, but undoing all that was unnecessary. This is an interesting chassis to service. It's nice to work on. It's just kind of weird, you know, the way everything kind of is put together like a puzzle. Now I did track down the service manual too, so I could follow their methods, and I did for some of it, but the disassembly and reassembly I'm just kind of doing on my own. Alright, and our low voltage plugs in here, back. There we are. Trying to get this low voltage wire routed. There we go. Alright, we have that in. Let's put our optics back in. Here's the optic block. Shutter's closed over the LCD. There's two screws hanging out the bottom, I think. Yeah, there they are. Let's set this back in. Alright, that's down. Let's plug this in. Alright, those are in. Let's put these guys back. Alright. Now we'll put the big boys back in. And and then we can do the rest. Okay, now the lamp basket. This actually isn't too bad. I expected it to be more of a hassle. Seeing that other capacitor was weird though. I've worked on a few of these and I haven't seen that cap go bad. Usually those green ones are decent. Yeah, they hold up pretty well, but not all the time, as we can see. Let's put this. Oh, come on. Get that wire chased under there. And then the ignition transformer. Alright. Lamp gets plugged back in. That's good. Put this back over it. Start getting our chassis screws back in. We're gonna go slow and work our way up. Alright, that power supply screw is in. I got another one over here. Got to make sure we get the right screws in the right places. We have a mix of fine thread and coarse threads. put this on to protect the lamp wire. Let's see, so that, I'm going to do that, tuck that in there. Yeah, there we go. Alright, and then these should be coarse thread, I think. Nope, fine thread. I know sometimes people don't like that I use a cordless drill driver, but just listen. See, you can run these without over tightening, it's not too hard. You do have to be careful, but you know, it's reasonable. Alright, and then this, although I can't remember if this has to go on before or after the what do you call it, after the main board is in. Just route this wire a little better so that we're ready for the fan. Alright, so I looked at this wire. I don't have that routed properly. This basket has to come back up for a hot minute. A little more. There we go. There we go. Much better. The big wire goes out the back and goes underneath, and the small wire is going to end up going like that. See, I was worried that the fan was going to pinch the wire, and it was where I had it. Now it won't. So let's just keep this ready. We'll set the basket back in. There we go. Alright, and then we can put this back in. Just got to get that one tab in. Yeah, there we go. Yep, I like it. So now we just got to put the, wait, is that not sitting flat? Okay, it will once the screw's in. Alright, now I'm going to put this one in by hand. I don't want to over tighten it. There we go. Perfect. Much better. Okay, so we should be able to put this back in now before the main board is in. As far as I can tell, all the brackets can still get put under it. Come on. Can't quite see the pin coming through. I'm not doing it backwards. No, that was the right way. There we go. Beautiful. Alright, wires are good. Let's get the metal and we'll put that in. We are almost ready for testing. We're getting super close. Alright. So it's this way. Yeah, this way. Hit it upside down. Now those in the middle. So far so good. And this one only had a couple screws, pardon me, if I remember correctly. Let's see, so it was, let's see, those, so it's gonna be this one, which is a helical screw. I remember correctly, this particular plate only had 2 screws in it. That one, and then this one. Yeah. All right. This is always the difficult part, getting all the Wires back into position. Making sure nothing gets pinched underneath, all that fun stuff. But so far, so good. 2, 3, 4, 5. Yeah, these all look good. All these wires are in place. I like it. Now, this cover goes on, but let's see if there's any screws that I put in. No, they're all going through that. So let's just get these plugged in, and I think what we're gonna do, yeah, I'm gonna throw a few screws in without the metal cover, just so we can test it. So let me do that right now, and then we'll get those wires plugged in and see what it does. I have high hopes. I think it's fixed. I feel like it's fixed. Alright, now let's just put one more in the front. Over here. Let's just do this one. Alright, and that feels good enough for the for testing. So fan, ballast control, those are still in. We'll do the LCDs last. Now our myriad of fans. So many fans. Oh, and I'll have to put the filter in. Oh, and I'll have to put a lamp in. I like it. Looking good. Let's see. That will bypass the switch. I'll show you that in a bit. Okay, wires are in. Let's put the filter in. Just move some of these extra tools out of the way. Move that metal cover. Alright, let's put the filter in. Why is that giving me a hard time? I want to force it. Don't forget about this. Make sure it's over. Let's see, let's let's just set it right there, and we can see what's going on. Alright, let me plug the lens in, grab the power cord, and we'll get this going. Forget it. Alright, let's get some power. Red light, standby, good. Green light. I don't know if it's going to fire up on its own or what. But I guess we'll find out in a moment. Nope, just in standby, good. Give it some power. Everything's flashing. What did I forget? What did I forget? Let me see. Interesting. Alright, so the problem, I didn't have the filter door wedged on well enough, so it would drop out and cause it to shut down. But you can see we got a nice bright picture now. I like it. There, we're in standby, or we're in, it's waiting for a signal. So let's shut her down and go ahead and put the rest of it back together. I love it. I'll be back with it set up in the long throw area. Alright, let's set this to on. Alright, we have picture coming up. Let's look at the screen. There we go. We've got a really nice picture. This is, of course, the famous Post 10. His channel's great. I'll put a link, of course. If you don't know Post 10, you want to know Post 10. His content's fantastic. And in fact, Posty, if you see this, congratulations on your upcoming marriage. Buddy, I think that's super cool. And good luck to you and the future Mrs. Post 10. So anyway, this is the picture. It's obviously inverted. Stairs don't usually go that direction. But it's kind of fun watching it this way. But you can see we have good picture. Power supply clearly works. I'm going to let this run for a little over an hour or two. The fact that it's on now should mean it's fine. They should be able to put it back into operation without any issues. So Yeah, I'm gonna call this one good. Not bad too. Only 2 capacitors. The chip ended up being okay. It was just a bad capacitor on the VCC for that switching IC, and then a bad capacitor on the 5-volt rail. So that was a good solid repair. I'm happy with that. So if you have any questions about your Sanyo PLC-XM100 or similar, go ahead and stick it down in the comments. I spoke too soon. After it was running for about an hour, it went to all flashy lights, and I went to start it back up and I heard a weird noise down in here. You guys listen. I'm going to turn it on. You'll hear the fan. Hear that? And then it's going to shut the lamp down in a second. And I go to that error. So we got to get into here, which is going to be interesting. I assume the main board's got to come out again and all that, so stand by. I'm going to pop all that out, and then you guys will pick back up with me once we get to the fan section. Got that main board out. So now I want to get this apart. I hope I don't have to take the optic block back out. I really don't want to. Of course, with the way this thing looks like it's assembled, I'm probably going to have to take everything apart. Airflow sensor. Let's see. Yep, that's going to come out. That's going to come out. Down here. And over here. I think there's one in the bottom too. Let's see if this is getting loose yet. Not really. Still pulling on the door. A little loose. There's a screw on the bottom. So it's loose, but it won't come out because this has to come out, which kind of sucks, but it is what it is. Yeah, you see, all that's got to come out. I think these screws are into the fans, but we'll see. So it turns out there are 6 fans. I pulled some out of a scrap unit so that I can replace them, because I'm not sure which one of these is making that noise. Could be all of them, for all I can tell. So let's get these up. Wrong size. Looking better. Let's try to get all these straight before I feed them back through. The one I took out, they were all tangled up. There we are. Much better. Yeah, I'll just do it this way. I may have to refer to the service manual to figure out where all these go, because they used to be tied with a zip tie to where they would fit into the only connector they were made to go into, and now I've got that size is all different, lengths are all different, so I may actually mark these 1, 2, 3. There we are, we got it all through. Let's see if I should mark these. So that's, which one's this? No. No. Some tape holding it all together. Let's get all that apart. See if I. Alright, this is assembled. I'm going to put this under here. I'm going to put this... Well, actually, I'm going to show you guys this. This is kind of neat. This is how the projectors tell if there's a problem with the filter. This little thing right here is an airflow sensor. If you want to look it up yourself, there's the number. It's D6F-V 0382-SA 18Y9R. It's made by Omron, and the way it works is that opening, and I think that opening, when air goes across, it feels the pressure difference between there and there. You know, kind of like an atomizer. As air goes across here, it's going to lower the pressure there and pull air in. And then it tells the projector, and if it sees something wrong, it says, uh-oh, not enough airflow, and it shuts down. And this actually lines up with, there's a little hole that sensor hole goes over. So, not all projectors use it, or not all of this type use it. I have another newer version that doesn't have one of those. They might just be checking temperature to see if the filter's clogged. Alright, we got that. Leave that. Okay. There's just so many wires. It's crazy the difference between a Japanese engineered projector and a mainland China engineered projector. One, I'm not saying one's better or worse or anything, it's just that they're very different. You can really see the engineering differences. And now I'm just gonna video me putting this back together for no particular reason. much quieter. Much quieter. Good picture. Alright, let's put it on the screen. There we go, we got a picture. Lamp counter's at 939 hours. There's plenty of time left on that. This looks good. It's way quieter too. So let me shut it down. I'm going to put the metal shield back on, remount the LEDs and all that stuff. So let's turn her off and do that. There we go. Picture's coming up. Listen to how much quieter that is now. It was a bunch of fans like this. SF6023BLHH1205E, 12 volt, 280 milliamp. Even though this is an older projector, we can see that, you know, even with the lights on, you get a pretty good, let's get that over a little bit. It's still very visible. You know, it looks good. So, I like it. I'm going to let this run for a little while again, so if you have any questions, even though I recorded this part, I'm re-recording it. If you have any questions about your Sanyo projector, PLC-XM100, or any of the other ones, go ahead and drop it down in the comments. If you need a lamp assembly for one of these, go ahead and check the description. If you don't subscribe to my channel, think about giving me a sub. It would help me out and doesn't cost you anything. But most importantly, if you got this far, thank you for watching.